In this video, I would like to present the indicator framework for assessing agroecosystem resilience. First, we need to talk about what resilience theory is. Resilience theory is normally applied to socioeconomic systems, but for agroecosystems, we can define this as the capacity of a system to change in order to maintain an identity. We can perform this assessment by using biotic indicators to conduct the assessment of the resilience of our system. The following are the primary 13 biotic indicators that we can use to assess this system. The first indicator is that the system is socially self-organized. An agroecosystem will likely self-organize in ways that are not compatible with human needs and growing the most efficient crops. So an example of this could be a garden engulfed by weeds or a wheat field overtaken by natural forest. Oftentimes we need to control this ourselves by means of adding nutrients to the system, removing pests from the system, or irrigating water into our system. The next indicator is that it is ecologically self-regulated. Ecological components self-regulate and reduce external inputs to the system, such as nutrients, water, and energy consumption. An example of a poor self-regulated system would be a crop field in the middle of a desert requiring a great amount of water to survive. They can't regulate themselves naturally and are thus less resilient. I remember growing up and living in Phoenix, Arizona, the middle of a desert, and seeing these huge crop fields everywhere. And on the sides of these fields would be these huge ditches for irrigating water made out of concrete. And I always thought, this seems ridiculous. Why are they growing plants here in the desert? So if that system failed, the plants would surely die, because obviously rainwater is not going to come anytime soon, at least. In highly resilient systems, there's a high degree of functional and response diversity. Diversity provides insurance against a total system collapse and allows us to plant the seeds for renewal. By having a large variety of elements in the ecosystem, this means if one element fails, the entire system won't collapse. Having a high degree of diversity will result in a system that is more resilient to shocks and disasters. How would the system in the desert respond to a drought or a failure of a system? In pumpkin patches, if it floods, we need a way to remove that excess water. Otherwise, all of our fruits are going to get rotten and we will lose money. For a highly resilient system, it needs to be optimally redundant. The critical components of a system are duplicated in case of failure. It reduces efficiency, and it also costs more money to duplicate these systems, but it does increase the buffering capacity, which allows us to recover during a disturbance. Having a high degree of spatial and temporal or time heterogeneity is defined as the lack of uniformity across the landscape and through time. Increasing heterogeneity supports a higher diversity of species. Increasing the intensity and frequency of production in an area will degrade the ecosystem. So if a farmer needs to make more money, they're not going to use crop rotation. And instead, the entire landscape is going to be uniform versus the lack of uniformity, which is what we want. By planting as many plants as you can on the land you have, you will increase production, but it will degrade the soil and completely get rid of all of its nutrients. In turn, we'll have to apply nutrients to the soil, which will then run off and get in our water supply, which is not good. By exposing our system to low-level events that cause disruption without pushing the system beyond a critical point, it will recover and become stronger and deal with these future disturbances better. One such way that we can do this is by employing horizontal resistance breeding to have a large degree of genetic variability to pests rather than a full resistance. So what this looks like is breeding our plants so that they have a large variety of genetics versus them all being exactly the same and all perfectly resistant to the same kind of disease or pest. While they are fully resistant, then we would have basically 100% of our plants survive. If that disease or pest transforms in some fashion or evolves, then we have no resistance. The ecosystem functions as much as possible within the means of our regionally available resource base versus having to bring resources into the system from afar. Our system needs to be able to recycle waste, such as animal manure, dead plant material. We have to rely on healthy soil, and we need to conserve our water. A resilient system has the ability to learn from our past experiences and share that knowledge to give the social ecological system more adaptability. For our system to be resilient, it needs to be globally autonomous and locally interdependent. The agroecosystem has relative autonomy from global control and influences such as international trade agreements, distortionary subsidies, and influence from large multinational corporations. Farmers and corporations should instead increase opportunities and cooperations rather than tighten the controls on the people producing the food. Our resilient system should be able to honor our legacy while investing in the future. Our systems today are based and influenced by past conditions and experiences. We can do this by maintaining heirloom seeds, combining traditional techniques with modern knowledge, and engaging our elders. We must build human capital. The system will need to be able to take advantage of resources that could be mobilized through social activity. We need to be able to invest in infrastructure and education as well. I think probably the best experience we have here in Northwest Arkansas of mobilizing our social activity is the farmers market that happens. That is by far the best way for producers to connect with consumers. And lastly, whatever systems that we are putting our time, effort, money, and subsidies into, it needs to be profitable. The farmers and farm workers need to make a living without having to rely too much on tax money and subsidies. This also helps to avoid burning all the nutrients from the soil once again, as farmers won't have to push the land too far to make a profit by increasing the yields. So when assessing a system to see if it's resilient, we can use these biotic indicators as a way to determine how resilient that system is.